Welcome to Engineering Simple. In this video, I'll talk about device numbers. It's almost like a must to know for those who are going to take the FE or PE exam. So let's start with a simple sketch. That way I can show why you need to know these numbers. So let's assume you have this is really a simple circuit. So you have a positive and negative. Basically, you have a battery here connected to these wires. So you might have something like, so you have a normally open contact and you have a device number 86. And here you might have select trip coil. This is the trip coil for the breaker. Then here you might have device number 43 and probably a push button. You can call it 52 CS control switch. That's connected here. So really this is simple. So basically, so you have the batteries providing power, but in this case, since this is normally open, there is no path to the trip coil, so the breaker will not be tripped. And you have a manual. This is 43. It's a switch. M stands for manual, so it's in the manual position. It's going to be in manual or automatic position. So there's no path, so the breaker will not trip. But as soon as the lockout, this is a lockout, and I'll go through the device numbers in names. Basically, we'll complete. So this will close. That means there's path here, and it will go to the trip coil and it will trip the breaker. Or if someone manually turns this switch here, then there's a path, and also you push this control switch, there's another path. So you have like two paths basically. Well, in the FE or PE exam, you might be given a simple sketch like this, and you are asked to describe. You might be given four options, like a lockout. Well, if the lockout is, completing the path, the trip coil will actuate, or so you will give something. So it's good to know what these numbers mean. So now let's go for the explanation of these kind of device numbers. Obviously, if you want the full information, you can go to IEEE standard C37.2. And please notice I'm skipping some device numbers, so I'm just kind of selecting a few that I think are important. But if you want the full list, you can go to this standard here. So like device number 11 is a multifunction device. So you can have, for instance, a relay that can measure current, voltage. It can do things with frequency and so on and so forth. So that's why it's called a multifunction device. Especially with digital relays nowadays, they can take a CT input, VT or PT input, and they can do math calculations to do all kinds of things. 21 is a distance relay. So when you have, say, a bus here, and you have, say, like a line in between another bus, basically a substation. So you have bus A, bus B. So somewhere here we'll have a distance relay. So you'll have a distance relay here, another distance relay here to make sure, basically to protect this line here should a line to ground fault or three-phase fault occur. 24, device 24 is a volt per hertz relay. typically used for in generation. 25 is synchronizing check relay. So when you have, so we have a breaker that's open, in the open position. For instance, let's just assume this is a breaker, it's in open, and you have a bus here, a bus here. So before you can close this breaker, you want to make sure the voltage here and the voltage here are kind of matching. You know, they have the same angle, because you don't want to close while there is a big angle difference, and there will be a problem. So 26 is a thermal device, so liquid or other medium. Basically, it's a thermometer, like a transformer. They have a thermometer that measures, you know, for instance, if this is the tank, if this is the oil inside the transformer, there's mineral oil or some other vegetable oil or whatever. You will have a thermometer somewhere here attached to the tank wall, because you know, as oil uh, temperature rises or increases, oil will go up or rise, and it will, this device here, thermometer, will indicate that. Device 27 is under voltage relay. 29 is an isolating contactor or a switch. So you might have a switch, a disconnect switch. So, and it has a, like a motor operator. Motor operator basically to control the switch, open it or close it. 43 is a manual transfer or selector switch. In the example that I started with in my sketch, I kind of showed the sketch with 43. So basically, you could have this switch, you could have like position that says manual position, or you can have another position that's auto or automatic, and you would turn the knob basically to which position you want to actuate. And why do you want to do that? Sometimes, say like if you are at the substation, you want to do some checking, probably you want to put in manual, but obviously once the circuit is kind of in operation or it's in service, you want to put it in auto. That way you let the system or the protection do its thing. Device 46 is a phase balanced current relay. So if the currents are unbalanced or negative sequence current, measured negative sequence current exceeds a set point, you would have a set point, then obviously it will do whatever you set it to do. And device 47 is a phase balance voltage. So 46 is current, 47 is voltage. So it measures unbalanced or negative voltage. Device 50 is instantaneous overcurrent relay. So there's no intentional delay. So if you set this device here, basically as soon as the measured current goes above the set point, it will trip the breaker without any delay. 51 is an overcurrent relay with time delay or inverse time relay. So basically you could have these two. Basically this here would go first. Somehow if it didn't work, after some time delay, this device here will trip the breaker. 52 is a circuit breaker. 59 is over voltage relay. 62 is a time delay relay. 63 is a pressure switch. 67 is a directional overcurrent relay. 71 is a level switch, liquid level. Again, if I go back to that transformer sketch, you have a transformer tank, and under normal conditions, oils, for instance, is at this level. So the liquid level gauge would be somewhere here, and it has like a float. As oil gets warmer and warmer, it rises, it goes up. So say like it moves to this level. So this float here, basically, it will make this uh, level switch change positions, and it could be connected to an electrical contact that would send an alarm or or do something, whatever you set it to do. 79 is a reclosing relay, so typically it's used with a breaker, because when a breaker is open before you, so you can use it to help with reclosing the breaker. 83 is an automatic selector or control or transfer relay. 86 is a lockout relay. It trips and maintains position. So if the breaker trips and you want it to stay in that position, you don't want it to accidentally reclose if there's a permanent fault. This lockout basically is a switch that will, after the breaker trips, it will lock it in place, and someone has to go physically to the substation and manually kind of restore this lockout relay. 87 is differential protective relay, using transformers, bus, and so on and so forth. So if you have a transformer, so you can have a, say like a CT here, so you'd have the relay somewhere here, and you have another CT, so you have the high voltage or primary low voltage side, and obviously it's measuring, so it's applying KCL, Kirchhoff's law, current in, you have current coming in, current coming out, so they should be the same. Obviously, if there is a fault current, the current will be different, so the differential relay will detect that. 89 is a line switch. So basically, if you have a bus here, right at the substation, you have a disconnect switch, and you will have the line. So you have some resistance, reactance. Then at the other bus or substation, you have another switch. So this would be 89. And finally, device 90, it's a regulating device. So if you have, for instance, an online load tap changer, you would have a device where you can set it to tell the tap changer to change taps, like tap in or out, add taps or remove taps out of the circuit in response to voltage. So for instance, if the nominal voltage is 12 kV line to line, say somehow the load was increasing and voltage dropped to 11 point, and this is just a hypothetical example, 11.75 kV, obviously the load tap changer will be asked to increase voltage by adding turns, So this device basically would be set to do that, You would give it some set points. So that was it for this video. Thank you and have a great day.